Hello and welcome back. We've been just looking at some types of functions that are going to be continuous pretty much everywhere or wherever they're defined. So for instance, polynomials will be continuous pretty much everywhere. It's nice smooth functions. Polynomials are perfect examples of continuous functions. Exponentials and logarithms are going to be continuous as long as we're careful and only look at where they're defined. Sine and cosine are going to be very continuous. If not a little bit wiggly, but that's fine. Tangent, we do have some discontinuity in there when we go up to infinity and we have to jump down and come up from negative infinity. Clearly, when we're jumping down, this is going to be discontinuous there. And I want to look at these last couple functions. The square root of x, I should do this over here. The square root of x looks like this. So it's basically a parabola that we've turned on its side. And we only have the positive root for the square root of x. So again, the square root of x is continuous on see here, 0 to infinity, because this is again just a nice smooth function. There's nothing crazy going on. We just don't want to talk about negative numbers and 0 because so even though our function is defined at 0, it's a little bit nicer just to talk about everywhere that's positive. So again, a nice continuous function, and then we have rational functions, and this is something that in the next section that we'll talk about. I'll go into more detail about rational functions and why they're continuous or not, and where these limits are. But first, I want to define rational functions. So a rational function is going to be a polynomial divided by a polynomial. And this is all a rational function is. So for example, 1 over x is a rational function. So is x squared minus 2 divided by x plus 6. This is a rational function. Any polynomial is rational. If I took x cubed plus 7, this is also a rational function because 1 is a polynomial, and I could take x cubed plus 7 divided by 1. So this is also a rational function. So the nice thing about rational functions is that they're made of polynomials, and we understand polynomials fairly well. They're nice and continuous, and it turns out that rational functions are continuous where they are defined. So for instance, 1 over x is not defined at x is equal to 0. I can't divide by 0. So as far as where is it continuous, so 1 over x is continuous on negative infinity to 0. And from 0 to infinity. So clearly, a rational function is not going to be continuous where it's not defined, because the function value doesn't equal anything there. If you can't plug a number into a function, it automatically can't be continuous there. So for example, this function is automatically not continuous at x is equal to negative 6, because if I plug a negative 6 in here, I'd be divided by 0, so I just can't in the first place. But anywhere that's not negative 6, this function will be continuous. And again, for a polynomial, this fits what we had before. There's no number that you can't plug into a polynomial. Every number works in a polynomial. So polynomials should be continuous everywhere. And we'll look at some of the reasons why these are going to be continuous in the next section. Again, specifically, we'll be looking at limits and how limits play nicely with, say, division or multiplication, addition, and subtraction. So until then,